What is the purpose of audio mastering? That's the whole issue here. The process of finalizing and creating a master of a musical composition for commercial exploitation. What do you need for mass consumption of a product? It requires standardization. Radio, internet, streaming, vinyl, CDs, film, TV. You need to be consistent from pieces of music. So you need overall sonic compatibility from one song to the next, if it's on an album's worth of material, or even between different artists. You need level compatibility. One song's not so quiet that you have to turn up your car radio and then the next one comes on and blows your head off. Very important to have level compatibility. Power compatibility. One song doesn't require so much subwoofer power that your amp is overstressed and that somebody listening to it can hear all the frequencies that are in it. So if I do a club mix geared specifically for a club, it may be different than something that I would record or master for a pop release for radio or for TV. Spectral compatibility, image and sound clarity. These things are really important in the overall mastering process. Early mastering, pre-magnetic tape, mastering was purely a mechanical process. It was basically so that they could record it properly and capture the sound. Recordings were cut with a stylus into soft metal or wax to create recording master, hence the term cutting a record, because they actually did take a stylus that cut into something as they recorded. Few recordings were manufactured for sale at that time. 1940s, magnetic tape came along. Magnetic tape was used as the master recording because the process of recording on tape was better sound quality, editability. All of these things existed on tape, but you couldn't just go sell tapes because not everybody had a tape player to play it on. It was too much of an expensive medium to be selling and commercializing with. The process of mastering became critical to that process when it came to, okay, how do we make an inexpensive medium that people can come and buy at the store and we can commercially exploit music? It became discs, obviously. Advances in electronics made it possible for program material to be sold on physical discs for commercial sale. That was the first step in really making the music industry commercially viable. Mastering started out as a technical process, and in the 70s, it was used to actually fix mixes. If you think about it, in the 70s, you're at the board and you're mixing a 16 track maybe, and you got to move faders and you got to change effects and you got to move pannings and you got to do stuff to make your master recording, and you're taking it off of a multi-track recording device going to a 2-track or a mono, but usually in the 70s would be a 2-track. That master tape that you're creating then goes and becomes manufactured into discs. Many times to set up the mixes were very expensive because everything was outboard gear, and you'd have to have stacks and stacks and stacks of gear at the mix studio, so you patch it into the tracks you wanted and what to do with it. I know it used to take us a day or two to do a mix by setting up all this gear and making it all work in harmony so your mix sounded right. And then if the label didn't like it, you'd have to go back and reset it all up for 2 days. Studios were expensive. Labels thought instead of spending that extra money to fix something just because the vocal was a little too quiet, they'd say to the mastering engineer, hey, can you make the vocal a little louder in mastering by taking that frequency and boosting it a little bit where the vocal is and sort of bringing out the vocal? Mastering engineers became really good at cutting certain frequencies and adding certain frequencies so that they could make the mix more balanced. That was great for the record labels. And as they became more and more disjointed in their mixing, the mastering engineer became much more critical to the record labels because it would save them so much money. And then you'd go and have a hit record with something that so-and-so mastered it, and then he became highly paid for his services. I created that record. That mix was horrible until I got a hold of it. And then the labels bought into it and started paying a lot of money for mastering engineers. They became famous. Bernie Grundman, Bob Ludwig. These guys became superstars in the mastering world, and they could demand a lot of money and get royalties on records and have managers and build their own studios. This is my studio. If you want to come here, you pay me my fee. And those guys worked a lot. So from 1989 till today, digital mastering for CDs, analog and digital mastering equipment, so you'd have analog and digital in the mastering labs. They actually called them labs, believe it or not. Mastering Lab is a famous mastering studio, And it was called a lab because in the beginning of mastering, it was really a laboratory process of how do we take the master material off the tape and make it translate as best we can to a vinyl disc. So they call it a lab. And these guys actually were technical engineers. They weren't really creative guys at all. They were just trying to make the music translate to something that they could sell. They do digital error checking, correction software, high quality dithering to create the highest quality recording that they could exploit. The mastering process was done in a way to assure sonic fidelity. When it was discs, which made a huge resurgence, vinyl has made a huge resurgence. The way a disc works is that a disc has a physical groove in it that the needle rides in, and small excursions of the needle translate into changes in an electrical impulse that comes from the cartridge, the phono cartridge. There's a needle on one end of a fulcrum. On the other end is a magnet, and there's wires around it. So when the needle moves, it moves the magnet through the coil of wires, kind of like a dynamic microphone, and so it sends a signal out of the turntable that gets amplified. Physical groove has to be very small, and the excursions have to be small, otherwise you can't get enough program material on a disc. It's a spiral, and it travels at a certain speed, and you can only get so much material on a disc. So groove width is dependent on how much program you can get onto the disc. So if the groove was wider, you could only have so many times around the disc before you didn't have any more disc left. The idea was to make the groove as thin as possible so you could fit as much material on your disc. The problem is that loud program material requires wider grooves, and low frequency energy requires wider grooves. So if the needle moves a lot, it translates to more energy being translated into the electrical circuitry, which, as we discussed from day one, low frequencies have more energy, so they take more movement, more physical energy to create, and there's more low-end energy in low frequencies. This was sort of a problem. How do we get thin enough grooves to get enough material on a disc, but also retain the bottom end? So size of disc, speed of the disc, turning, the width determines the length of the program that can be held on the disc. The common speeds were 78. The early discs were 78. 45s, 33 and a third, singles, EPs, and LPs. Singles, obviously one song on each side. EP was usually 4 songs on each side. LP was usually 10 songs, maybe 8 if the songs were long. And the groove was cut by a variable pitch cutting lathe, heated up with a vacuum that captured what was being cut out of the vinyl disc. So that was called chip. And so they had a lacquer, which is a very soft kind of a plastic, that would be cut into by a heated stylus, and it would make the wiggles in the groove. The groove represented the acoustic sound of the program material, but you realize this was all just a physical cutting. There was no electronics involved in it at all. It was just a physical disc that if you put it on a turntable, it could recreate the electronic impulses that were represented by the acoustic sound in the first place. So the wiggles inside the disc, inside the grooves, represented actually the signal or the acoustic sound in the first place. This is a good picture of it. Different size discs. And you see that the 45 has a larger hole in it. They did that so that they could save material, and then of course sell you one of these. The spindles. Used to go and get them for like 49 cents, 59 cents, up to 69 cents for 2 songs. And you'd have to have the spindle or you couldn't play it. So the way that they did this, let's talk about the RIAA filtering. The way that they actually achieved this concept of limiting the low end so the groove could be thin enough, but also not losing all the bottom end in the music, was in the mastering process. They would do all their sonic corrections like they would do today, except they put one more filter on the final program material before they cut with the lathe, before they cut the actual lacquer disc. And it's called RIAA filtering. There's a very specific curve of frequencies that they would take out bottom end, quite a bit of bottom end, 15 to 20 decibels of bottom end. And then they would have a specific curve everybody in the world agreed upon. When you'd play back the record, the disc would be lacking all this bottom end, then whatever you would play it on, whatever amplifier your turntable was plugged into, had a phono in. And the phono in was made to reinstate all of this bottom end. So they'd have a filter that actually put back all of the bottom end that you filtered out in the first place to make the disc. So it's almost like compression. It's almost like zip filing something, and then at the other end of the journey, unzipping it. So they would do that so that the vinyl disc could actually hold enough material and not have wide grooves, but still not lose all of its bottom end. The processing is level control, frequency balance, editing, pop and click removals, stereo field widening, alter phase to make things seem wider than they are, high quality dithering,